Our naval weapon systems are designed to meet the tactical needs of the fleet. When the enemy threat is limited in strength and speed, there may be plenty of time to prepare for an encounter, time to manufacture, to test, and to repair the components of a system, to assure that it will satisfy the necessary fleet requirements. With the utmost effectiveness. When the enemy threat is greater, there is an immediate need for a greater number of weapons. There is also a need for increased manufacturing ashore. This could result in the loss of a common standard of measurement between the individual manufacturers. The resulting incompatibility between the various components of the system would weaken the tactical effectiveness of the fleet. When any components are manufactured, it is expected that a certain percentage of them will not measure up to the designer's specifications. Therefore, an accurate method of testing components must be established at the manufacturing level to determine which items will be certain to work properly and which will not. But even good components will not remain that way forever. As time passes, they deteriorate. Fewer and fewer will be able to do the job required of them. Therefore, they must be retested at the fleet level to make sure that the components will always be ready to work as they were designed to work. As the requirements of a weapon system increase, so does the need for more testing equipment. This equipment is produced to operate within specific design tolerances. And like components, test equipment itself decays. And with time, more and more of its instruments are unable to do their jobs. When used, these inaccurate instruments will accept items with bad components at either end of the spectrum. Some of these instruments will drift, accepting bad components at one end, while good ones at the other end are rejected. Still other test instruments may behave erratically, accepting and rejecting items at random. Such a wide variation in tests results in costly and unnecessary handling and retesting of good components. Even worse, it results in the use of bad components and weakens the fleet's combat potential. With today's highly complex tactical situations, the combat readiness of the total weapon system depends on the accuracy of adjustments that link its many components and subsystems together. The failure of the entire weapon system could be due to an error in position fix of a few arc seconds, or to a communications delay of a few microseconds. Or the system might fail because of a fire control error of a few millivolts, or because of an equally small variation in a guidance correction signal. Many of the components which make up a highly complex weapon system are extremely delicate and decay at a very fast rate. Within weeks of their installation, some are no longer doing the job required of them. It may be impossible to detect this decay, except through the continuous use of complex monitoring equipment, which transfers information from one subsystem to another. Or by the regular use of test equipment, considerably more precise and delicate than the items under test. As the testing and monitoring equipment decays, though it may appear to be functioning properly, it will in fact be giving increasingly erroneous readings, upon which incorrect adjustments to the system will be made. Thus, it is essential that the testing and monitoring equipment itself be tested and adjusted, to be sure it stays within its design tolerances. Without this assurance of a higher level of tests, we can expect a gradual decrease in the combat readiness of the fleet. It is the responsibility of the captain and crew of each vessel to maintain the reliability of test and monitoring equipment by arranging for its testing. The job of testing and adjusting items of test equipment to meet their proper tolerances is called calibration. Calibration relies ultimately on the establishment of some very precisely determined standard of measurement, to which all testing instruments can be compared with confidence. But a single standard alone cannot be used to calibrate the huge number of testing devices that will need this service again and again. And to supply every vessel, depot, and factory with the most accurate standards possible would be much too costly. So less expensive standards of measurement must be manufactured so that all test equipment can be calibrated more readily. However, to ensure against the decay of this standard and to maintain uniformity of measurement, all calibration facilities must have their standards undergo regular periodic comparison with standards of higher accuracy, and so on, so that a minimum number of standards will be necessary for comparison to the highest of all standards. Such a system of calibration standards is essential to assure a uniformity of all testing and measuring equipment. Calibration also assures the precise integration of all the components, modules, and systems of each vessel. This reliability of a ship's test and monitoring equipment depends on the crew in meeting test requirements and calibration schedules, and on the captain in providing direction for their accomplishment. Actual calibration, or the testing of test equipment, is occasionally performed by the equipment user, but more often it is handled by over 100 Navy calibration laboratories located at contractor facilities, shipyards, air stations, and fleet tenders around the world. These labs are staffed with personnel especially trained in metrology, the science of measurement. The calibration instruments used here are in turn tested and realigned by more exact calibration equipment located at Navy Standards Laboratories. There is still more precise equipment which compares the equipment of these labs with the highest of all standards of measurement, at the National Bureau of Standards. This network of calibration and standards laboratories is carefully integrated and standardized by providing each lab with identical equipment and identical technical procedures and training. Periodic calibration schedules are established according to the known decay rate of each piece of test equipment. These schedules vary from periods of 1 month to as much as a year or more. Periodic calibration cuts down on costly and time-consuming rejection and reworking of good items, as well as reducing the erroneous acceptance of bad items. Periodic calibration assures the captain and crew of each vessel that their tests are true tests, that the natural decay within their testing and weapons system will be detected and corrected. Why do we calibrate? Without calibration, our costs go up and our tactical efficiency goes down. With calibration, we are confident that our test equipment and weapon systems will operate as designed.